However, one of these gas giants is a planet that teases the rules of evolution. Astronomer Jeff Marcy discovers something shocking about a planet orbiting a star called 16 Cygnus b, located some 70 light-years away in the constellation of Cygnus, the Swan.
The planet was clearly in an elongated orbit, bringing the planet close to and then far from the host star. And this, of course, defied our expectations based on our own solar system, where all of the planets go around our sun in nearly circular orbits like phonograph grooves in a record.
Like a giant yo-yo in space, the gas giant swings back and forth across its solar system. That's like the Earth swooping 25 million miles, more than 40 million kilometers closer to the Sun, then slinging past Mars all the way out towards Jupiter every year. And like all of the gas giants in our solar system, this yo-yo planet probably has an entourage of moons. Marcy speculates that one of these moons could be similar to Earth.
And here's where the interesting story begins. Imagine a rocky moon with lakes, oceans, maybe streams and waterfalls on the surface. The moon orbiting its planet, the two of them orbiting the host star.
Unlike the airless moon that circles the Earth, this moon is a world with extreme seasons. On Earth, the seasons are caused by the tilt of our planet. Here, they're caused by the elongated orbit.
These poor planets that are in these elongated elliptical orbits suffer terrible changes in their climate throughout a year.
As they make their closest approach, the yo-yo planet and its moon are blowtorched by the star. Summer begins. The atmosphere on the Earth-like moon is savaged by raging storms. Category 5 hurricanes on Earth are tiny eddies compared to the monster vortexes that form here. The clouds thicken as the water evaporates.
Temperatures rise dramatically. Any water or gases would heat up, and indeed the oceans would boil into steam, so you'd end up with a big steam bath.
During the peak of the summer, the entire moon is smothered in temperatures of more than 400 degrees Celsius. This is the closest approach to the star. During its 26-month orbit, the summer season is barely 2 months long. But what a season! The planet and its moon swing away from the furnace of the star. Temperatures fall to ranges we would find temperate and comfortable. With the coming of autumn, the rains return to the parched and roasted moon. Dry ocean basins are replenished, and the seas arise to form new shorelines. Tranquility prevails as the yo-yo planet and its moon slip into the deep freeze of winter. Now over 200 million miles, more than 320 million kilometers from the star, the daytime sky is dark. Temperatures hover around minus 160 degrees Celsius. The oceans freeze, and the polar ice caps expand across the moon's surface into a globe-girdling sheet of ice many kilometers thick. Winters are long, lasting 17 months. With the coming of spring, the sun looms large in the skies over this hapless moon as the ice cracks and melts violently. Huge icebergs carve into a stormy and fast-rising ocean. For two preciously short periods, during the spring thaw and the autumn rains, the climate on this Earth-like moon is balmy and comfortable. At a distance of 93 million miles, or 150 million kilometers from the star, roughly the same distance as Earth from the Sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. The conditions here are just right for life.
If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But then if you're right in the middle, it's just right.
Every star has a Goldilocks zone. Where that zone is depends on the size and temperature of the star. In our solar system, Venus marks the inner boundary and Mars the outer boundary. Earth and its abundance of life is right in the middle. The Yoyo planet passes through the Goldilocks zone twice a year, for 3.5 months during the spring as it races inbound, and again in the autumn for 3.5 months as it hurtles back into the colder reaches of space. Could life survive the conditions outside the Goldilocks zone?
There could be life forms that are smart enough to hibernate, as do animals on the Earth during the winter season. If this sounds fantastic, I offer you the tidal zones on the Earth. On the tidal zones, life proliferates, of course, near the seashore, and they do so despite tides. The water coming in, covering many of the life forms, the water going out at low tide, and yet those species survive perfectly well.
The strange cycle of the Yoyo planet's orbit creates fleeting conditions suitable for life, but also for death.